Alrighty, good morning, everybody. I hope you had a lovely rest of your day yesterday, and that you woke up feeling nice and refreshed today. Maybe the sound of the rain was peaceful, I don't know. So, good morning. Today we have got a Desmos activity that is freshly minted. Just hot off the press, finished it like 2 minutes ago, so we'll get going with that here shortly. But first, I want to do the last example that we didn't get to yesterday in our lesson, in our presentation. So I want to do that example, and then we'll jump into our Desmos activity and hopefully learn some stuff today and get a little more clarification on our testing a claim. All right. So let's do sharing of the screen. Yes, we must share the screen. Excellent. All right, so get the stuff set up correctly. All right, so here we go. Here's our last example from yesterday, dealing with our section 9.1 on the basics of significance tests. So this example is opening a restaurant. You're thinking of opening a restaurant and are searching for a good location. From research you have done, you know that the mean income of those living near the restaurant must be over $85,000 annually to support the type of upscale restaurant you wish to open. You decide to take a simple random sample of 50 people living near one potential location. Based on the mean income of this sample, you will decide whether to open the restaurant there. So part A here is state an appropriate null and alternative hypothesis and be sure to define your parameter. All right, so in this case, our null hypothesis, again, my pen's gonna be all glitchy, but is what it is. All right, we're dealing with mean income, so our parameter will be mu. All right, and remember our null hypothesis will always be equal to a value. The value we have is 85,000. The alternative, the thing that we're kind of hoping for, right, is that people need to have more than 85,000, right? We have over 85,000. Mu is greater than 85,000. Where mu is the true mean income of residents near the restaurant. Right, so this is a way that we can write this all in kind of one phrase here. Right, we can say H naught mu equals 85,000. Alternative, mu is greater than 85,000, where mu is the true mean income of residents near the restaurant. There we go. We've done it all in one sentence. We've stated our appropriate null and alternative hypothesis, and we've defined our parameter. And when they say define a variable, define your parameter, that means tell me what it is. What does it represent? Is there anything I can clarify for this part of the question? Our null and alternative hypothesis. Okay. The question. All right, so let's see. Same context. Part B here is now describe a type 1 and type 2 error and explain the consequences. These are potential consequences of making each of this type of error. All right. So type 1, this would be finding. Don't know why my pen keeps doing this. It's really annoying. Convincing evidence that the mean income, or that mu, exceeds $85,000 when in reality it does not. All right, so again, that type 1 is essentially you found evidence that said reject the null hypothesis. We have evidence for the alternative, and our alternative here is that mu is greater than 85,000. Right? If we make that kind of error, right, the consequence is that we're opening the restaurant in a location where residents can't support it. They don't have the income. All right. And so then when it's asking for consequences, it's literally asking for, like, in real life, what would happen if we made this mistake? If our data was wrong, so to say. And then type 2. Right? This would be not finding convincing evidence. That mu exceeds 85,000. When in reality, it does. So now we did not reject the null hypothesis, right? And we did not have evidence that the income was high enough. And so what happens? We don't open the restaurant in a location that could have supported it. And we're just going to paraphrase that. All right, so once again, if you have not joined the activity, please do so. This is your opportunity to practice. If you cannot join the activity for some reason, please make sure you're at least following along on the shared screen so you know what we're doing. And you might have the opportunity to learn, which is awesome, which is what we want. All right. So here we go. Yes. Ooh, all over the map. All right, and I'll read through what you guys said about this check-in here after class when I have time. But it looks like we're kind of all spread out here, kind of in a range. It's pretty spread out. Cool. All right. So here we go. Let's get this going. All right, so I'm going to kind of do what I've done in the past here, and I'm going to open up screens as we go, but I'm not going to close the ones behind it. So I've opened up screen number 2. All right, and the first few screens here are just review from what we hopefully learned about yesterday. All right, so this first screen is just about how to state an appropriate hypothesis. All right, and in a significance test, the null hypothesis has the form H0 parameter equals value. Parameter could be mu, could be p, could be sigma. Right? The ones that we're mostly going to be dealing with, though, in this class will be mu, population mean, and p, population proportion. And that will be equal to some value that's made evident in the context. The alternative hypothesis has one of the forms. Alternative parameter less than value, parameter greater than value, parameter not equal to value. All right. We need to read the context carefully to determine the correct form of the alternative hypothesis, meaning is our goal to have something less than a value? Is our goal to have something greater than that given value? Or are we just interested to see if it's just not that value? It could be bigger or smaller. And again, hypotheses always refer to a population. Be sure to state H0 and H sub A in terms of population parameters, P or mu. Never X bar, P hat, anything like that. All right. Interpreting p-values. The probability that measures the strength of the evidence against a null hypothesis is called a p-value. Right? We can essentially think of the null hypothesis as like kind of if we think of the judicial system, right? People are assumed innocent until proven guilty. The null hypothesis is the assumption of innocence. And you try to find, as like if you're the prosecutor, you're trying to find evidence against the innocence. Right? So the null hypothesis is the assumption of innocence, so to say. And so we find evidence, and we boil that evidence down to the p-value that either supports or is against the null hypothesis. Probability computed using assuming H0 is true, that the statistic would take a value as extreme as or more extreme than the one actually observed in our sample, is called the p-value of the test. So we find the probability of getting a value similar to, like, equal to or less than or equal to or greater than the actual thing we find in our sample, assuming that H0 is true. So given H0 is true. In other words, the probability of p hat occurring, assuming that p is the true proportion, is a p-value. This is an example. Small p-values are evidence against H0. Large p-values fail to give convincing evidence against H0. Right? Large p-values is like you just don't have enough evidence. It's not convincing. Significance. All right, this is now how we apply the p-value to a significance level. Right? When trying to determine significance, we can compare the p-value with a fixed value that we regard as decisive, called the significance level, written as alpha. When we use a fixed significance level to draw a conclusion in a significance test, we can use the following logic. If my p-value is less than alpha, then we reject the null hypothesis and we have convincing evidence for the alternative. If our p-value is greater than or equal to alpha, large, then we fail to reject H naught, and we do not have convincing evidence for the alternative. And this is kind of like, it's another form of graphic similar to the table that we saw yesterday. And this directly relates to p-value. And then lastly, we have our type 1 and type 2 errors. If we reject H naught, when H naught is true, we have a type 1 error. If we fail to reject H naught, when the alternative is true, we have a type 2 error. We can also consider this to be if we find convincing evidence that the alternative is true, but it isn't, type 1. If we do not find convincing evidence that the alternative is true, but it is true, type 2. So we can kind of word this in terms of the null or alternative hypothesis if we want. And then we have the table that we saw yesterday, giving us that nice little layout between type 1 and type 2 error and correct conclusions. All right. Is there anything I can clarify before we move on? So we'll go to our first question here. We have 2 questions in this part. For each of the following settings, describe the parameter of interest and state appropriate hypotheses for a significance test. According to a website, well, we have our 2 contexts here. I'll allow you guys to read those. I do want to show you, so I recommend going to the shared screen at this moment and look at what I'm doing. We have some options here. If you want, if you feel savvy this morning, you can upload an image as your response here now. So that means you could write this by hand, your responses, take a picture, put it in the cloud, upload it here. That's an option now, okay, in our little submission here. If you're going to type your response, to make the symbols, right, on your keyboard, you will type capital H, then underscore, which is shift, and the little minus thing next to the 0 on your number pad, and then 0. Take your cursor and highlight it, and then hit this little math type thing, and it'll convert it to that lovely H sub 0. Right? You can do the same thing for H sub A to get that notation. You can also get more keypad options when you're in that function, the like math type, but it doesn't give you like the alpha and the things like that, just options. All right, so to get those notations, that's how you'll do that. Or again, if you're feeling nice and savvy, you can just write it by hand, take a picture, upload that to the cloud, and put your picture in here. That's up to you. All right, guys, so let's pause here. I know that a lot of you guys are still working on these 2 questions. I'm gonna look at question number 1 on this page. So a lot of you guys, we're on the right track here so far with question number 1. You have a good idea for the null hypothesis. I've seen some varying responses for the alternative. And remember, when we're dealing with the parameter P, that's a proportion for the population. It's not having to do with the size of our sample. It's for the entire population of the large high school. So if you guys want to switch to the shared screen so you can see what I'm typing up on the screen. That might be helpful. So I encourage you to take a pause here, take a minute and watch, and then I'll give you more time to complete your work on these first two questions. So we're going to have h sub 0, and that will be p equals 0.85. Right. I have h sub a, and that is going to p is not equal to 0.85. Now notice, and this is just because I've had time in this program a lot more, I'm typing everything out without math type. I'm going to highlight it, hit math type, and look, it's nice and pretty now. The math type here doesn't always cooperate with what I want it to do, so I type it out first, and I find I have more success. All right, so we have h naught proportion of equaling 0.85, alternative not equal to 0.85 is the true, or p is the true proportion of students at the large high school (8 hours per night). Right, so the less than 8 hours per night is not part of our parameter or our hypotheses, right? Because we're not interested in the average hours of sleep or anything like that. We're interested in the proportion of students getting less than that. Right. Is there anything I can clarify with this example? Anything I can explain better? All right. So again, we're going to give you a little bit more time to work through and complete these first couple questions. If you're in the math type setting and you open the keyboard that pops up here, keypad, you have less than equal to, greater than equal to, greater than, less than, if you're looking for those symbols. Otherwise, how some of you have typed it is totally fine. I get what you're saying. And typing in math is a little tough if you're not familiar with it. So you can get is fine. We're going to talk about the second question now. All right, so in here, we're dealing with the census, 2010 census. They said 10 questions in 10 minutes. That's all it takes. And this is their claim that it'll take about 10 minutes to complete, including time for reviewing the instructions and answers. We suspect that the actual time it takes to complete the form may be longer than advertised. Right, so the null hypothesis, right? The assumption is that we're going to say, okay, well, we're going to assume that they're correct, and it is 10 minutes. The average time is 10 minutes. We want to, we're hoping to disprove that and say, no, it takes longer than 10 minutes. All right. And so this is what we end up getting. And I also want to draw you guys' attention to how this is written, this so-called math verbiage, right? This is a capital H sub 0. We're using that lettering because it has significance, so to say. And then colon, not equals. The equal sign is reserved for things that are equal. This is just, we're saying what this thing is, right? This is our assumption. This is our hypothesis, is that mu equals 10 minutes. And our alternative is that mu is greater than 10 minutes, where mu is the true mean amount of time it takes to complete the census form. Okay. If you're trying to type mu, the way to do that in Desmos is you're going to hit backslash mu, highlight, and hit your little math type button. You're in the math type. I think if you just, it doesn't cooperate for some reason when you're in there that way, so I always type it ahead, highlight, and it works. Because Desmos has some letters saved and some not. So, and again, because we're dealing with an average amount of time and not a proportion, like we could possibly deal with this question and say it takes, they claim that, over, that 50% of the population can complete this in 10 minutes. We don't think they're right. Then we'd be dealing with proportion. But since we're dealing with the actual whole number and averages, that is now mu. We're dealing with a mean. Right. So any questions? Is there anything I can clarify? All right. So I'm opening up the next question here. And this again is dealing with our significance. All right, so lefties. Simon reads a newspaper report claiming that 12% of all adults in the US are left-handed. All right, so right away, we're dealing with proportions. He wonders if the proportion of lefties at his large community college is really 12%. Simon chooses an SRS of 100 students and records whether each student is right or left-handed. His hypotheses are stated below, and this is from the question we did yesterday at the end of class. Right, so we have our hypotheses here. The null hypothesis is that the proportion is 12, right, that they are correct. And our alternative is that it's just not equal to 12, that it could be more or could be less, but it's not that. Or P is the true proportion of lefties at Simon's large community college. So in Simon's SRS, 16 of the students were left-handed. The significance test yields a p-value of 0.2184. What conclusion would you make if alpha equals 0.1? Justify your answer. All right, and so you might want to refer back to screen number 4, right, where we look at how a p-value relates to a given significance level. That might help in constructing your answer for this. All right, and make sure that your response, when you're typing it out, or again, you have the option to write this by hand and then just upload a picture, if that's easier for you. You need to construct it, and you need to write your response in terms of this context. It's not enough to just say, we reject the null hypothesis because we have evidence for the alternative, or vice versa, right? Say what it is that you have evidence for, essentially, in context. All right. There we go. We're going to talk about this one, guys. If you're still finishing up your response, that's totally fine. I'm going to discuss about this on the shared screen. So again, we have a p-value of 0.2184. Our significance level, our alpha, is 0.10. So we have a p-value that is greater than alpha. Okay. And based on this idea here, if the p-value is greater than or equal to alpha, we fail to reject the null hypothesis, and we do not have convincing evidence for the alternative. Okay. So that means, let's see if this is gonna, this is what we end up getting. Because the p-value of 0.2184 is greater than alpha equaling 0.1, right, we fail to reject the null hypothesis. We do not have convincing evidence that the proportion of left-handed students at Simon's College is different from the national proportion. Anything I can clarify on this? Any questions, comments, concerns? Right. Next question. All right, and now we're going to interpreting a p-value. So in context, what does this mean? Or actually, sorry, this one is why is it wrong? So when asked to explain the p-value in the previous exercise, lefties, right? A student says there is about a 22% chance that the null hypothesis is true. Explain why the student's explanation is wrong. Why is this not a proper interpretation of the p-value? All right. So think about that. And again, there's a little bit of student support down here. If you want to click on that, there's a little hint. Maybe that'll help, maybe it won't. Alrighty. So we're going to talk about this one. So again, when interpreting this p-value, right, which is what the student is attempting to do here, they're saying there's about a 22% chance that the null hypothesis is true. Right, this is wrong. This is not how we interpret the p-value. If we look at, screen 3 here in our little set of notes for interpreting p-values, right, this is this probability measures the strength of evidence against a null hypothesis. It is a probability computed assuming that H0 is true. All right, and it's the probability that a certain outcome occurs. Right, it's the probability that the thing that we saw happen in our sample, whatever that outcome is, occurs given that the assumption of H0 is true. All right, and so then when we look at this here, there's a 22% chance of getting the proportion of lefties that Simon found, which was 16%. Assuming that the actual proportion is 12. And how we calculate that p-value will happen in the next section, and it'll actually help make this make a little more sense. However, what we get, and one way of kind of wording this in a nutshell, is given with this: either H0 is true or it's false. There's no middle ground. There's no it's true sometimes and false sometimes. So there's no probability of it being true or false. It either is or it isn't, 0 or 1. Right? And that is, again, because the p-value tells us the probability that a certain outcome occurs when we assume that we have the true parameter. Right? So we're assuming that H0 is true here. We're not trying to say what's the probability of its truth, because things don't have a probability of truth. They either are or are not. We have probabilities of getting a certain outcome based on that assumption. Not sure if that helps or not. Is there anything I can clarify, or can I explain that in a different way, maybe? I don't know. So again, I think this will make more sense once we get into actually dealing with proportions and means in section 9.2 and 9.3, and how to calculate a p-value will help us understand what it means. But we'll get there. All right. Here's what we're going to do. I'm going to skip to the last few slides here. I'm going to open everything up. All right. We're going to skip the next one, which is blood pressure screening. It's got a few parts to it. We may or may not get back to this at another point in time. And we're going to go to, there's a multiple choice question here, and The next screen has a bunch of multiple choice questions attached to the same context. All right, so we're going to run through these last ones. I'm going to give you guys 7 minutes to work through these multiple choice questions. All right. Make sure to read them carefully, and then we will talk about these and go over what these solutions are. All right, guys, we're actually I'm gonna stop our timer here. We're gonna run through these real quick. So, for the mice in a maze, we have a mean time of 18 seconds for the maze. The researcher thinks that a loud noise will cause the mice to complete the maze faster. That means in less than 18 seconds. All right, so that gives us the fourth option. The null hypothesis is mu equals 18. The alternative, mu is less than 18. We are hoping to find out evidence that it is less than 18, so that is our alternative. We're going to assume that the original 18 seconds is correct, though. That's our null hypothesis. All right, this one here, all right? They want to know if the sales tax is going to be accepted or not before they put in all the effort into this. So they get their null hypothesis, p equaling 0.5, right? Because they need a majority of people to approve this thing. So their alternative is to be less than 0.5 for the proportion. All right, a type 1 error in the context of this study occurs if the city council, so again, type 1, right? That's meaning they reject the null hypothesis when it is actually true. So they reject the null hypothesis and they say, okay, we do have support for this bill, which means they find convincing evidence. Let's see if we can get this here. That a majority of residents supports the tax increase when in reality at most 50% of the city residents support the increase, because if we're equal to 50, we're at most 50. Right, which should be the second option. Right. In the sample, 158 out of 300 residents support the increase, a proportion of 0.527. The resulting p-value is 0.18. What is the correct interpretation of the p-value? Right. The first two options are not correct because they're not assuming the 50% is correct. Right, we're assuming 50% of the residents support the tax increase. Right. Based on that assumption, right, there's an 80% probability that the sample proportion would be 0.527 or higher by chance alone. So our third option there, that's what our p-value tells us, that there's an 18% probability that we'll have that value or more that we found from our sample. Based on the p-value of 0.18, which of the following would be the most appropriate conclusion? All right. We do have a large p-value. So again, we go to our significance scheme. We're assuming a large p-value, so we fail to reject. We do not have convincing evidence for the alternative. All right. So because p-value is large, we're looking at we fail to reject. And we have a few different options for failing to reject. And we do not have convincing evidence that more than 50% of the city residents support the income tax increase. This. All right. And again, that is because we fail to reject the null hypothesis. All right. So that means we're assuming we keep the assumption the null hypothesis is correct, and we do not have convincing evidence that we have what we wanted, which was the alternative. Okay. All right, so I know I kept you guys a little bit long today. I wanted to try to help you guys understand these things a little bit better, because this is the basis for what we'll be doing for sections 9.2 and 9.3 in conducting our tests and our significance tests. I should have practice problems and solutions available later today for section 9.1. I apologize, I don't have those ready yet. But most of the, at least a good portion of the chapter 9 module is ready as far as the resources are concerned. You have the study guide for section 9.1 and the PowerPoint presentation, example videos. For section 9.2, I have the presentations loaded in the resources. I do not have my study guide yet, but I do have all the videos from AP Daily and the textbook linked into those resources on that 9.2 and 9.3 resource page. So that should be ready. I don't remember if I published it, but it will be published later today if I don't. All right. Other than that, that's the end of the lesson. Stop pasting that. If you have any questions, comments, concerns, anything I can support you with this lesson or previous lessons, previous assessments, please make sure to let me know, send me a message, something, ask for help if you need it. And besides that, I should be seeing you guys next week. Have a great rest of your week and a great weekend.